Good afternoon, everyone. Thank you for taking time out today and being here with us. Today is the third episode of our Gov Cloud Webinar titled Empowering the Human Eye with AI. My name is Catherine and I'll be your host for today. Before we begin, let me share with you how this Gov Cloud series came about. In the recent years, organizations have leveraged various technologies to improve their business operations, from cloud computing to artificial intelligence, and of course, for the public sector, this is no exception. So as a company focusing on digital transformation, Toppan Ecquaria has helped various government agencies transform their operations from migrating their systems onto the cloud to implementing data-driven solutions like AI. Along the way, we pick up some learning points that we thought it could benefit the industry. So here we are, we put together a series of Gov Cloud webinar, and hopefully it will be beneficial to you too. In the last two episodes, we focused on topics related to government compliance solution on the public cloud. In the first episode, we talked about how beyond authentication and authorization, content inspection could be an important feature of API gateway that was designed for the government system. The second episode was on the DevSecOps and the different stages for government on the public cloud. Okay, let me do a time check first. The time is now 1:02 p.m. Since like most attendees are in, so let's kickstart the webinar. Hi everyone, welcome to the third episode of our Gov Cloud webinar series titled Empowering the Human Eye with AI. This episode is jointly brought to you by Toppan Ecquaria and our sister company, Toppan Leefung. Today's topics revolves around how technologies like text analytics and computer vision can help to reduce human error and improve our life, our jobs, and the future. My name is Catherine. I'll be your host for today. And with me together are Wei Lun and Cassidy. Wei Lun is our AI consultant from the innovation team in Toppan Ecquaria. He has worked with various government agencies on the projects to improve their operations using machine learning. Wei Lun will start off in the first part of the webinar, speaking on unlocking the power of text analytics. Moving on to the second part of the webinar, our guest speaker Cassidy from Toppan Leefung will be sharing with us how security is evolving in this COVID-19 pandemic, moving the world towards touchless biometric security via the facial recognition in unique conditions. Okay, I guess you guys now should be getting excited to start the webinar. But before we begin, let me do a little housekeeping to run through. First, this is a live webinar. We'll be recording the session, which we'll be releasing on our YouTube channel. So after this session, do head over to our YouTube channel. Make sure you subscribe to our channel and give us a big thumbs up. If you have any questions during the presentation, do pop them into the Q&A box. The Q&A tab can be found at the bottom of the webinar screen. Lastly, if you wish to invite us to present to your team or have questions after this session, do drop a note to info@toppanecquaria.com. So now, without further ado, I will turn over the time to Wei Lun.
Okay, thank you, Catherine. So, hello everyone. My name is Wei Lun. I'm an AI consultant from the innovation team at Toppan Ecquaria. In today's webinar episode, I'll be talking about unlocking the power to unstructured data with text analytics. So the reason why we have chosen to talk about unstructured data is because of the following trend as predicted by the International Data Corporation as seen over here. By 2025, 80% of data will be unstructured data. So unstructured data refers to data such as images, videos, and documents. Among these three types of unstructured data, I'm sure many government agencies have repositories of text-based documents. These are documents accumulated over the years and will continue to grow in years to come. Therefore, there's potential in these document repositories that can bring quite a lot of value add to your organization. I'd like to explain to you in this webinar how our product Ecquaria Machine Learning can be used to unleash the potential of your document repositories. So EML can solve a variety of problems as seen in this diagram. So while we have started off with structured data, as explained in the 2018 Rethink seminar, we quickly realized the growing importance of unstructured data. Therefore, we have also built up EML capabilities for unstructured data such as images and text. In fact, in last year's Gov Cloud seminar, we also showcased some computer vision and natural language processing NLP capabilities. This year, in this Gov Cloud webinar, we will be exploring the NLP capabilities of EML even deeper. In particular, we will be covering these three capabilities. Each of these capabilities correspond to some common challenges faced by government officers. We will show how EML can provide solutions to those common challenges. So let's take a look at the first challenge I'll be talking about today. The first challenge is that officers may spend a lot of time reading through long documents. We know that documents cannot be avoided in government agencies. It is simply part and parcel of a government officer's job scope to read through long documents. So the thing about these long documents is that officers actually do not need to know every single thing in a document before they can do their work. Yes, the details in the documents are needed for completeness in the entire processing workflow. But officers only need to know some of the important details, such as the red boxes in this example. And these red boxes roughly take up only 5% of the entire document. And yet, officers still have to comb through the entire document to be able to find out those important details. And this process of reading through the entire document can be time-consuming. So it would be great if there is some means to automatically extract the key information from the documents. And that's where EML can offer a solution by providing a summary of each long document. So with the summary created by EML, officers can read the summary provided by EML instead of the whole document and save time as a result. So nothing is more convincing than an actual demo. So let's take a look at a summary that EML makes. So let me switch over to the demo screen. So in the current demo screen, what you can see is an EML summarizing tool. To summarize the main text, we just copy the text into this text box over here to see the summary. So let's take a recent article from CNA about former Malaysian PM Najib arrives at the court for 1 MDB case verdict. So let me copy over this article. So roughly we should see some case details about this Najib 1 MDB case in the summary. So let's take a look at see what EML summarizes for this main text. So this is the summary. So it does talk about 1 MDB, One Malaysia Development Berhad, as well as some more details about the case, and also what will happen if the verdict turns either way. So I think this summary does work, but let's say if the officer would like to see a longer summary, this is what the officer can do. So by default, I just set the summary to be a length of 3 sentences. So officers can easily change this value to 10 sentences. And then when I click on summary, officers can then see a longer summary. So an alternative to toggling the summary length by sentences is to toggle it by percentage. The default option I set here is 10%. And 10% simply means that the summary will be 10% of the length of the original article. So I click on summary, and then I can see that now this is a summary that is 10% of the article. So these are just some configuration tools you can do for a summary, nothing too fanciful. So let me switch back to my slides. And yep, that's the demonstration for the EML summarization tool. So at this point, let me just do a quick check to see if there are any questions. So I think looks like there is one question. So the question is talking about how does EML summarization work? So there are 2 types of answers for these questions. I have a long answer and I have a short answer. So what I intend to go through now is the short answer, and that will be the high-level summarization process. So actually for the subsequent demos later on, for every demo that I go through, I'll also be going through the high-level concepts applied for each demo. So if let's say the high-level explanation for the various concepts has captured your interest, and you'd like to find out more details, you can also post a question asking for more details. Then I can go through the details for each concept in the Q&A session later, after my main section is over. So for now, let me just quickly explain how summarization is done at a high level. So from a high level, the EML summarization process is a very simple 2-step process. First, I split the text I want to summarize into sentences. So in this case, this main text here has 6 sentences, and therefore I've split it into 6 sentences. And then step 2 is to use EML to do a comparison. EML will then rank each sentence from the most relevant to least relevant, and then the most relevant sentences as determined by EML will be used as a summary. So in this case, the most relevant sentences are sentences 1, 3, and 5, and therefore sentences 1, 3, and 5 are used as a summary. So yeah, it's a simple process. So now let me move on to the next challenge. Challenge number 2 is about how the current process is cumbersome to find similar cases. So based on our experience of building systems for government agencies, we know that many systems involve a workflow that looks like this. An applicant makes an online submission, and then the officer views the submission online. And then after viewing the submission, the officer will make a decision on the submission. So a decision can be things like approve or reject, or to decide which superior officer to route the submission to. So from time to time, before making a decision, officers may want to have some reference to learn how to handle the current application. And these references come in the form of past similar applications. So how do officers find past similar applications? Some of you may be able to relate to this guy over here. This is how many government officers feel when searching for similar cases for references, whether in the physical domain or in the digital domain. They'll first have to pick up a few past applications, manually read through that, and then see if it's a suitable reference for their current application. So you can see the process of reading through these past applications is very manual and therefore cumbersome to officers. And therefore, it will be great if there's some means to automatically recommend similar cases to officers. And what EML can do is to recommend past similar applications based on semantic meaning. So using the semantic comparison capabilities of EML, EML can then recommend the top few most similar applications to officers. So in this way, officers just need to look at what EML recommended, and they no longer need to manually dig up cabinets or folders of applications to dig up for past applications for reference. So now let me show you a demo of how using EML to find similar applications can enhance the application's processing workflow. So first, let me give you some context so that the demo will be clearer for you to follow. So for the user interface, what you'll be seeing is the backend application processing view of a government officer. And the role of this government officer is to read through alerts made by the public on possible exploitation of the elderly. So if I were to map this example government officer role to a real agency, this is likely an officer from the MSF, Ministry of Social and Family Development. So of course, this demo I'll be showing is not the actual MSF workflow. I'm just using a simplified version for demo purposes. So after reading through alerts, what the officer needs to do is this. The officer will then make a decision to launch further investigation or decide that the alert is nonsense and therefore ignore the alert. So with this context in mind, let's take a look at the demo. So let me switch over to my demo screen. So over here, now I'm the government officer that is looking through an alert made by the member of public. So first, I can see some details of the member of public that made that alert. So these are just some metadata, which is not really our focus. Our focus will be on this section, what the member of public submitted for the alert. So the alert will contain information such as who is the perpetrator and what are the observations made by the member of the public. So EML will be using this information over here, the text find the observations, to find similar text based on semantic meaning of this current text. So let's take a look at what this text is about. So in this case, there seems to be an old lady who is getting conned by someone else, conned by another younger lady. And the old lady seems to be in a fragile state of mind. So let's take a look at what EML recommended as past similar applications to that current description of the observation. So in this case, we can see a few other past similar applications. They all revolve around an elderly lady who is in a dead state, similar to dementia, some mental condition, as well as Alzheimer's over here. And also the presence of some expensive stuff, such as jade pendants. Above we have jewelry, and then here is also gold jewelry, here is also a diamond ring. So roughly what EML will do is to not just search for keywords, you'll be using the semantic meaning of the observations and then recommend past similar observations to officers from there. The officers can take a look at the similarity score to see for themselves how similar the current observation is to the past similar observation. So an example of how an officer will be using this past similar application for reference will be to look at the alert status made for each of those past similar applications. So in this case, out of the 4 top similar applications, 3 of them have a status of investigation launch, and only 1 of them is alert ignored. So most likely for the current observation, if I were the officer, most likely I will be selecting the launch investigation option because it really looks like there's a good enough case to merit a further investigation. So yep, this is the demo for the enhanced application processing workflow, how EML's semantic comparison capabilities can be used to find similar applications for you and enhance the application processing workflow for you. So now let me go back to the slides. And yep, as for each demo, every demo I'll go through a concept. So now I'll go through a concept of EML semantic comparison. So it's just a high-level explanation. It is also a very simple 2-step process. So first, EML can do a semantic comparison between the main text and other past text fields or documents. So it will be doing a comparison as such over here. And then step 2, the top few semantically relevant past text fields are then used by EML as recommendation to the officer. So officers can use these past similar applications as reference for the decision-making process of the current application. So now I've gone through a demo for semantic comparison as well as run through the high-level concept for semantic comparison. So at this point, let me just do a quick check to see if there are any questions. So, okay, looks like there is one incoming question. So let's see how this question goes. So the question is finding similar applications only for alerts? So the simple answer is no. Alerts is only used as a demonstration in my example just now. It won't be just for alerts. In fact, there are endless possibilities about how finding similar text can be applied in your IT systems. And in fact, that's what I intend to go through now. I'll go through some other possible use cases, and then you can see if any of the use cases are applicable to your current system. So just to bear in mind that the list of possible use cases I'm about to show you, they all center around getting references for officers. So basically that means that we will use EML's find similar text capabilities to recommend references for officers. So the use case I demonstrated just now, they can fall under the categories of observation and issues. So that was a demo for the MSF, Ministry of Social and Family Development. We can easily replicate something similar at other ministries, such as MOM, for example. At MOM, maybe it's not about reporting elderly, it'll be about reporting bad employer practices. So we can use the similar use case just now to find similar reported observations about bad employer practices, and then officers can then use it as reference from there. So same thing for any other ministry. You can use it at teachers, at MOE, or even organizations such as SPF if there are any bad practices to report about police officers. Yeah, sorry, all these examples now seem to have a slightly negative tone. So of course, we are not catering for such problem statements with a negative tone. So what we observe also is that recently in the systems that we built and in the tenders that we take part in, we noticed common requirements such as building inquiries or feedback portal. So this is where finding similar inquiries or feedback might be useful for officers so that they can have reference on how to handle the incoming inquiries or feedback. So these are just examples on short, relatively short text fields. We can also use EML find similar capabilities for long documents such as grants or proposals application. So it might be useful for officers to see applications with such long documents and then use those past applications for reference. And I believe long documents is not just purely from front-end applicants. In the back-end system, we understand that it is also common for agencies to conduct audits, enforcements, or inspections. So all these actions might have reports, and officers might be using these past similar reports to guide them on writing their current report for audit, enforcement, or inspection. So that's the end of this slide. The examples over here are not exhaustive. We'll be happy to see what other use cases you might have that can use these find similar capabilities. We can see what use case you have in mind, and then we can conduct a feasibility assessment to see if it's really a good fit, to see if EML is a good fit for your use case and for your organization. So now let me move on to the final challenge for my section. So challenge 3 is about how keyword search doesn't yield the desired results at times, and therefore rendering the keyword search irrelevant for my usage. So we understand it is common nowadays for systems to have a keyword search engine for users to search through the documents accumulated over the years by the organization. And the way the keyword search works is just a familiar Control F function where you go and do Control F and search for the keywords you want in the document. So while keyword search can be convenient in that it allows users to really tap on the data collected by the organization, it does have some limitations. Sometimes when I do a keyword search, I do not see the results I want, and I feel like this guy over here, getting nothing from the search results. So just to illustrate the limitations of keyword search further, let us consider the terms machine learning, robotics, NLP, natural language processing, as well as artificial intelligence. So the relationship among the 3 terms at the bottom is that they are all categories of artificial intelligence. They are all a subset of artificial intelligence. What happens when I search for artificial intelligence using a keyword search is that the results will show me documents that contain the exact words artificial intelligence. But then we can have a document that for machine learning, and this machine learning document only contains the words machine learning and don't contain the words artificial intelligence at all. And this document will not appear in the keyword search results because it doesn't contain the words artificial intelligence. And hence, this is a shortfall for keyword search. So a smarter search for artificial intelligence should also include results for machine learning, robotics, and NLP, even if these documents themselves do not contain the words artificial intelligence. So it'd be great if there's a search engine that can be smarter and return better results for the users. And that is where EML can provide an alternative method for search in the form of semantic search. So what EML will do for a search query is this. EML will first understand the semantic meaning of the search query, and then return search results that have the most similar semantic meaning to the search query. So going back to the example on artificial intelligence, using this semantic search approach, a search for artificial intelligence will include results for machine learning, robotics, and NLP, because these 3 terms have close semantic meaning to the term artificial intelligence. And with that, let me now do a demonstration of EML's semantic search feature. So let me switch to the demo screen. And over here, you can see a similar looking search interface. So let me first do a demonstration of a keyword search. And the term I will search for is machine learning. So how we can very easily see how a keyword search does a search for machine learning, because it will highlight where it found the term machine learning and then return the search result over here. So every single search result that you see over here contains the words machine learning. If I were to do a keyword search for artificial intelligence, I will also see a similar concept of the documents highlighting the terms artificial intelligence. But now let's take a look at semantic search. Let's take a look at what the semantic search results will offer when I search for artificial intelligence. So okay, it'll just take a quick while. Okay, so now we can see the search results. So first results we can see is about robots, and robots, as explained just now, is indeed a category of artificial intelligence. So this result here is a relevant search result. And we can also observe that in this text over here, it doesn't contain the exact words artificial intelligence. And yet, because robots has close semantic meaning to the term artificial intelligence, it's appearing in the search results over here. So same thing here for machine learning and also neural networks, which is neural networks, just for info, is a form of deep learning, which is also under machine learning, and therefore is a relevant artificial intelligence search. So roughly, this is how a semantic search powered by EML can offer an alternative to your keyword search. So we also have applied some EML features to the search details page. The search details page is where you'll be after clicking on an article in the search results page, for example. So let's take a look at what EML features are provided in the search details page. So there are 3 tabs over here. The first tab, I will be seeing the actual long document itself. So you can see this is a very long document, 41 pages long, talking about this CHIPS system. So now let's take a look at the second tab to see what kind of results EML can offer. So over here at the top, you can see a summary of the long document you saw just now. So how this summary is done is the same way as what I showed you just now in the summarizing tool. So in this search details demo that I'm showing you, we set the default length of the summary. So in this case, we set 2 default lengths. One default length for the short summary, as well as another default length for the longer summary. So this is just to show you how we can cater for the different summary options in EML. Of course, if the officers are savvy enough, we can include similar summary configuration tools over here and embed it right inside the same search details page. So officers can use that configuration tools and then really configure a summary that is to their liking in the search details page. So that's the first EML feature that can be observed in the search details page, the summary feature. The second feature is about finding similar documents. So yeah, it's very similar to the application processing workflow you saw just now. You can see all other similar documents as well as the summary and the similarity score. So clicking on the view document part will easily just lead me to the same search details page. Then I can see the same search details such as the document itself and EML results. So now let me move on to the last tab, which is a visualizer. So this visualizer is, you can interpret it as how a layman can interpret how the EML model behind the scenes works. So the orange document here is the current document. That means the long document that I showed you just now. And then the blue dots over here are the nearby documents to the orange dot. So they are nearby documents in relative to the entire document repository. And by nearby, what I mean by nearby is that they are the most semantically relevant as determined by EML search. So hovering over my mouse over here allows me to take a look at the article. So just a simple, not too bad simple tool for you to see other documents. So that's the demo for the search. Let me go back to my slides. So I've now covered the demo for the document search engine. So the concept for the search engine I won't be going through because the concept for semantic search is very similar to semantic comparison, and I've already gone through the semantic comparison high-level concept. So I'm nearing the end of my section. So let me just do a quick check to see if there are any new questions. Okay, so I'm seeing some questions, but I'll try my best to answer all these questions later on in the Q&A session later. For now, I try not to disrupt the flow of the presentation, and then I'll just do a quick wrap up. Then if time permits later, I will go through those new questions in the Q&A session. So just to wrap up, this is a summary of what we have gone through just now. So we have the challenge of being time consuming to read through long documents. With that, EML can provide a summary solution. And sometimes it is very cumbersome to find similar cases, and EML can automatically recommend to you past similar applications based on semantic similarity of each of those past documents. And for the last challenge, sometimes it is you encounter a situation whereby the keyword search doesn't yield desired results, and what EML can offer is an alternative search to the keyword search in the form of semantic search. And today's topics only cover 3 of those EML capabilities. We have gone through some of these other capabilities in past seminars, and there are still quite a few that I have not gone through yet, whether it's past seminars or to the current webinar. So perhaps those are topics we can go through in future seminars or webinars. Just to take note, these EML capabilities, they are not an exhaustive list. We are still growing our capabilities, and we also look forward to sharing with you those new capabilities next time in future webinars or seminars. So yeah, now I've come to the end of my section. I hope you have some interesting takeaways of what EML is about and how it can be useful for you. We'll be happy to answer any queries you have, and we can also have a further discussion to see how EML can add value to your organization with AI elements. So now I'll hand over to Cassidy. Cassidy will be talking about responding to the COVID-19 pandemic with computer vision. So now let me just stop sharing my video and also to stop sharing my slides. So over to you now, Cassidy.
Thank you, Waylon. Ladies and gentlemen, thank you for this opportunity to speak with you. Let me share my screen. Thank you. My name is Cassidy. While Waylon has covered AI from the linguistic and the semantic angle, I'll be covering it from the field of computer vision. So literally, it's empowering the human eye with AI and extending the capability of human vision with machine vision and machine learning. And I'll also cover a bit about how we can use deep learning networks to quickly respond to challenges thrown up by the ongoing COVID-19 pandemic. While my colleagues in Toppan Ecquaria developed their own IP and platforms, I come from the security systems division, which is primarily focused in system integration. So what we work with quality technology partners on a global stage to bring about to the market highly viable and tried and tested technology solutions. Today I cover tech offerings from two partners, namely Paravision and UpAsia. Paravision is a US company that's centered around facial recognition, or for short, FR. They work extensively with security device manufacturers such as Bosch, Motorola, to embed their technology into edge devices, as well as with system integrators and solution providers like Toppan to bring best of breed FR tech to the market. UpAsia is a homegrown Singapore-based technology provider with IP in deep learning networks applied to various computer vision challenges such as vehicle plate, license plate recognition, object classification, incidents management. Their founding members actually hail from Institute of System Science, part of NUS. Now you might know that they are subsumed under A-Star umbrella by now. So who is Paravision? They are a US company that's headquartered in San Francisco in California with development offices in Toronto and Vancouver, and very strongly tech with 75% of their staff in the field. The machine learning team is very strongly fueled by 6 PhDs and postdocs, so there are a lot of brilliant people in their team. So in a nutshell, as mentioned, Paravision is mostly about FR. So they deliver one of the most accurate FR engines in the market, ranked globally top 5, measured with the most recent NIST benchmarks in March, as well as there's the most recent one in June in 2020, for both a one-to-one and one-to-many matching methodologies. NIST stands for the National Institute of Standards and Technology. It's an agency as part of the US Department of Commerce, and it's a de facto biometric benchmark laboratory for the world, generally accepted as the go-to agency to determine the quality of a biometric engine. Paravision's engine is lightning fast. So you can see here, we are able to handle less than 35 milliseconds to identify a face out of roughly about 15 to 20,000 records database. Of course, it's scalable with hardware. You throw at it more cores, you get better performance. The rest of the actual search takes about only 4 milliseconds. The rest of the 30 milliseconds are actually used in image handling and what we call encoding of the face to a searchable template. The FR engine is toughened against GAN, which is GAN stands for Generative Adversarial Networks, is a form of attack. And other forms of presentation attacks are what we call, generally called spoofs or fakes. They are deployable on-prem, on cloud, on edge, or hybrid, or all the above. So you get the very flexible deployment pattern that can be customized to your any conceivable deployment environment. And lastly, they are proudly the West's best performing FR engine ranking very strongly against the best of breed coming out of China and Russia. Broadly, the functionality is as follows. You have on the left side here from detection all the way to liveness and anti-spoofing. These are all the capabilities that they have. Of course, finding faces is a key first step. If you can't find a face in an image or a stream, you can't process the face. This is very difficult in challenging environments where the presentation angle is not fully onto the camera. Image quality is very important too, because if you throw garbage into your deep learning network, you basically get psychotic results. You won't get a correct accuracy that you're looking for. So garbage in, you naturally get garbage out. Verification and identification are two sides of the same coin. One-to-one matching for verification and one-to-n matching for identification. Roughly, it means if one-to-one, you could come with a live face and then maybe an NRSC number. And based on the NRSC number, the system will pull out the reference enrolled face and then match you and then determine whether you are who you claim to be. Identification mostly comes from the surveillance angle, where you throw in a face. Maybe you get a face from a pole cam on the HDB void deck, and then you throw it into the system, and then you want to find out who this person is out of the 4.5 million faces in the national database. Liveness and anti-spoofing, we'll talk more about it in a little bit later on, because in the current day and age, it's when you have a system, people will try to defeat it by various attacks, and you want to be able to be hardened against this so that you can have a reasonable sense of security that you are not being fooled. On the right side are the deployment choices that you have. On SDKs, you have low-level libraries and in various OSs that you can develop very tight integration with your desired platform, especially on the edge processing capabilities. It's very exciting. And then, if for those who want to have quick to market solutions, then the best way is via the Docker containers that they provide. You can reach them through REST APIs, literally out of the box. So we can deploy literally in a matter of minutes FR capability out of the box. And then, of course, they work on Intel Open Eno, which is a computer vision framework from Intel, and NVIDIA's TensorRT, which is a deep learning framework from NVIDIA, especially catered for computer vision. This is the ranking according to NIST. As you see here, this is one-to-one, and the leaderboard is dated June 2020, very, very recent, just last month. And one-to-many is March 2020 benchmark. As you can see, roughly out of the one-to-one, we are the fifth behind all this. And most importantly, there is the first among the Russian and the Chinese engines over here. And on the right side, very strongly, we are third behind SenseTime from China and NEC from Japan. One-to-N is a very demanding and very difficult benchmark to fight against, naturally, because you are searching across the entire database with your probe image, and there's no help from an NRIC or ID number at all. You have to do pure face matching to achieve the match. Most importantly, you'll see that Paravision is the only company that is found in the top 5 of both sides. So those are good in one-to-one are not good in one-to-many. And those are good in one-to-many are not good in one-to-one. So with Paravision, you get best of both worlds, basically best of breed. And of course, those among us in the coalition of the willing, if you have a bit of worry about Chinese and Russian engines, then this is a US engine. A lot of the vendors in the China and Russia space are very close connection to quasi-state research institutes. But for Paravision, they are wholly private-owned company. No connection to CIA or FBI or any of those. The first step in face detection, of course, is FR is, of course, face detection. So over here, I have a video to show you that demonstrates Paravision in performance against Amazon, Face++ by MacV, which is a Chinese engine, and then Microsoft. As you can see here, the number of faces that we picked up by the Paravision engine is way more than any of the closest competitors. Even very small faces right at the back here, very limited pixels across the eyes are being picked up. Of course, the more faces you pick up, the more likely you'll get better accuracy in matching. Why? Because it's statistics. You throw in more samples, you get more matches. And then you can, of course, then work the curve. As opposed to less samples, you get less ground for you to generate the matching results. Over here, another demo. We're using a commodity IP camera. You will notice that for Paravision, they focus a lot on our COTS equipment. So it's no special equipment that's required. This is just a commodity IP camera mounted in a typical lobby or in front of an elevator. And it's going at 1080 pixels, 15 frames per second. Very run-of-the-mill garden variety cameras that you can get anywhere nowadays. So you note is that the face detection is very fast, and even with very aggressive side profiles, you will get good quality faces being detected. The white boxes are the face detected. And over here you can see even the quality is anywhere from 80% to about 50%. Even so, the confidence scores are in the high 90s. But the deep learning engine is very, very good at sussing out faces out of a frame as well as matching. Of course, much faster than a human eye can possibly accomplish. Now, if you take a FR engine, the separation between men and boys, if you will, is the scalability and ability to handle challenging real-world environments. So I've met a lot of eager computer vision students who tell me they can write a FR engine using an open source code such as OpenCV. You can download it from the internet. But I have no doubt they can. But when you place these homegrown engines in the real world, with real-world optic problems, lighting problems, presentation problems, you will find that, as the Americans say, you're not in Kansas anymore. This is where the men and boys are differentiated. Here we have a very challenging use case, which is a vehicle access control environment, which is thrown to us, and we have met head on, and it came out very, very well. The problem space that's given to us is that the vehicle is not stopping, and the windows are up. Let me play this video. The video has been deliberately slowed down because otherwise you'll go too fast. So Tiffany is is a friend in Paravision, and you can see her even though with this heavy glare to the windows, you can see that the recognition is very high. Okay, and the most important thing is, oops, sorry. Let me do that again. Let's go to this part. If you notice this person here, he's just using an iPhone to do this footage. And nothing fancy, just a normal iPhone. And you will see that amazingly, through the window, his reflection is being picked up. And we actually recognize him. You may have missed it. Let me go back a bit. Okay, I don't know whether you saw it, but there was Thomas. So that was Thomas. And even this person here, which is Doug, is also picked up. Okay, so you can see Doug, right? So essentially, although you might say that, okay, the spurious pickup from the screens being reflected is not a good sign, but we can always filter that out using a whitelist. So it may be a security guard that you're with a body-worn camera that is doing this, and then you can filter out the security guard's face as a known whitelist, and then the non-habit process. Next, I'll show you presentation attack. Before I go there, I'll mention about GAN, which is GAN. The GAN is a generative adversarial network. It's an attack method where artificial vectors are created. It's deliberately created to exploit the known deep learning network's performance, challenge the envelope. And the purpose is to inject perturbations in the data to introduce errors into the AI weightage and thresholds. So it's like knowing an exam question beforehand, exam paper beforehand, then you prepare a script that's scripted to ace the questions. So other attacks are simpler, basically showing a picture or video. Let me play this video for you, and then you can see the effect of that. So at first glance, you see that it's a spoof, still a spoof. And you're wondering what's going on. This looks like a fairly good video of a person in front of a camera until you zoom out and you realize it's an iPad. It's in front. Immediately you see this is a real face. And on over here, the depth map coming in from the Intel RealSense camera, which have a capability of percepting contours, is feeding back that that's a contoured face, and this is a flat face of Mark Zuckerberg. All right, and this is real. So you can see that the snap, how fast the PAD is. As this person approaches, you will see that it's invalid or suspicious at first because it's too far away. As it comes nearer, and then the network is able to say, okay, that's a good contour, and therefore it's a good face. I'm aware of time, so I'm going to go a little bit faster to cover the information. I have about 5 minutes more to go, so just stay with me. So you'll be wondering, okay, what's it got to do with COVID-19, which is part of the subtext of this presentation. Well, the pandemic has really turned the world upside down, and there are many challenges facing us. It used to be very simple. Daily tasks and routines has been totally turned around. So one of the strengths of AI and neural networks and deep learning networks is the speed at which you take the existing engine and retrain with different inputs and make it look for different things and retask it for another purpose. Basically, you create a new, different model. The same computational underlying computation is there, it's just that the models are different. So in a short space of 2 weeks, Paravision is able to develop mask detection and social distancing management, just 2 weeks. All they need to do is take their current FR model, pivot it to something else. Let me play the videos for you so you are able to sense what they have achieved. This is mask detection. Again, Tiffany. When it's red, it's basically no mask. So it's detecting that it's not wearing a mask. Although the matching for Tiffany is in 100%, 99%. The moment she puts on a mask, it turns green. So this is a real time capture and real-time processing. And you can see the speed of the neural network and the computer vision libraries that's used to support. So very useful in mask wearing enforcement, which is quite prevalent now. Next is in the cloud. This is more of a surveillance mode. This is not in the US. This is someplace in Hong Kong. Naturally, because it's kind of hard to find a bunch of Americans that are willing to wear masks and walk in the public space. This is a bunch of people walking. And the moment they walk into the zone of interest, those that are red boxes are basically unmasked. Even the guy playing a saxophone on the left side with a very aggressive side profile can be picked up as being unmasked. And lastly, social distancing. Again, they take the core engines, and if you look at the guy that's going to walk across the bottom here, you see him is in green until he gets close to this two and it's immediately red. And then it's going closer to the car, it's still green, and then meets with the driver, it goes red again. Okay. So there are a lot of challenges here because of the shadows, things that look like humans but are not humans, and the movement and the angles. All this has to be sifted out by the computer vision algos. Going to the use cases, of course, you know, in the public sector, the private sector, you can deploy them in the following. These are some examples of the possible deployments in the lobby, in access control, even in payments and customer experiences. This is exciting, especially with the oncoming of efforts in NDI and in Smart Nation. And in defense and intelligence, where Toppan is it's more prevalent, as well as government. You can see the use cases in the identity dominance, in based infused security. Identity dominance is a fancy word for basically saying knowing more about your enemy than an enemy knows about you. And then generally there's also base security. So there are ongoing, current ongoing initiatives right now, the SAFs. I can't talk too much about those because of OPSEC and NDA, but suffice to say that there are several initiatives that are ongoing right now with the SAF on base security. So live case, this is a very interesting live case, and it is a Japanese petrochemical facility. We will classify it as a P1 Kins equivalent. If you want Singaporean context, this is likely be like a Jurong Island. So a lot of dangerous chemicals and lots of stuff there that goes boom and potentially injure a lot of people. So definitely you want to put some security there to make sure that correct people go in and not anybody can just go into such a facility. So the challenge is, again, the vehicle doesn't stop, the windows are up, and additionally there's rain. So we cater to 120 test scenarios and we came up very, very well. This is one of the footage of the hundreds that we went through. You can see this is at night. Okay, immediately, if I pause here, you can see this person is already identified as C204, and the quality is only 60%, but it's already a 99% confidence. This guy here, even though it's right at the corner there, we already got his face, and it's a 30% quality, but as you progress, you would get a green box. Okay, this is with the car interior lights on. The challenge is the third row, which is very difficult to get because their faces are very small and they're obscured by the, I see this guy is done. And you look at this one, also done. And this guy is obscured by the label, but the moment he goes here, boom, we got him. Okay, we have zero false acceptance. That means everybody that's in the car is identified as the correct person. Out of the database of 607. This is again the same thing, except that we use external lighting, so the performance is even better. It's almost no challenge. With FR, I like to say that we own the night because, in fact, nighttime we excel even better than day. Okay. So, in the interest of time, I'm going to skip the next two slides because it's just basically a summary of what I've already gone through verbally. So this is a deep learning process, basically just to tell you what goes on in a typical deep learning process.
Hi, Cassidy. Sorry, in the interest of time, I think you might want to wrap up at the last slide so that, because we left only 5 minutes for the Q&A.
Okay, so
yeah.
This part here, unfortunately, I can't go through you because it's more theoretical. Let's go to some of the more of the videos and then I can wrap up.
Thank you.
Yeah. So this is a typical scene in AMK somewhere. And you can see the deep learning engine is being put to test to detect traffic lights, buses, trucks, cars. Even if you're a person walking by with an umbrella and holding a bag. I can't tell you the type of bag yet, whether it's a LV bag or what. Maybe with better cameras I can, right? This is social distancing. You can see how a typical mall scene, we can detect persons either by size of human object, or something we call pose estimation. Pose estimation detects the arms and the legs and the head, and how this joins together to act in a human-like manner. So a Doraemon here is ignored because that's obviously not human. Detection of fire. Okay, so you can deploy this in HDB blocks. Nowadays, the PMD fires are a big problem, and nobody detects that until somebody looks over the other block and then discover that there's something burning. So maybe this might be a possible use case. Even very small spots like this, okay, is detected. And then lastly, I'll give you a comparison between Paravision and our homegrown face detector to prove that actually we do have very good tech. So the yellow one is UpAsia, which is our local detector, and the other colors are from Paravision. So overlaid, you can see that the speed is equivalent and the accuracy is equivalent. This is just a face detection. There's no FR coming from UpAsia. Okay, so this leads me to this is my last slide. I'm going to hand over to Catherine and for the Q&A and the wrap up. Thank you, everybody.
Thank you, Cassidy and Wei Lun, for the engaging presentations and demo. Now we will take some questions from the audience. Okay, let me see the questions. Here's an interesting one for you, Wei Lun. The questions: do we need to have a lot of past record for EML to be successful? What if there are no past record, as appeal complaints may be unique? So Wei Lun, please answer.
Okay, thank you, Catherine, and thank you to the attendee for the question. So the answer will be we do need some. We do need some past records, but we do not necessarily need a lot of past records if you're thinking of hundreds of thousands or millions of records. There's no fixed number to the quantity of past records. It all depends on your use case. So let's say if your use case is on complaints, as you have mentioned, and there are two types of complaints, severe complaints and not so severe complaints. It will be good to have some severe complaints in the repository as well as some not so severe complaints in the repository. Then from there, most likely EML can understand the semantic meaning of the current complaint and then recommend to you severe complaints if, let's say, the current complaint is indeed a severe complaint. So yeah, just to sum up, we do need some past records, but there's no fixed number on how many past records are needed. It all depends on your use case. So if the attendee who posed the question has a use case in mind, feel free to share with us more details. Then from there, we can analyze and then see how best to design the EML solution to suit your needs. And yep, that's the answer for the question.
Okay, thanks, Wei Lun. In the interest of time, we will only be able to take one more question. So let me see, do I have another question here? Oh, there's one. Cassidy, someone from the audience asked, for social distancing, how do you judge the distance between the different people? Is it translated to real distance in terms of like 1 meter between the person? Yeah.
Well, that's a very good question. Actually, I had no time to cover that because of the interest of time, but I'm glad you brought up that question. So in a typical VA or video analytics calculation, the simple ones will be just calculating the pixel distance, which is obviously not accurate enough because you have a perceptive distortion and you have distance. So for a true distancing calculator to work, you will need other information. So the angle of the camera, the depressional angle in the camera, the anchoring it on a fixed object that will not move, like a tree or signboard or something that is in the field of view that will not move, allow you to create something called a trigonometric or geometric model. And from there, you do estimation based on this as a scale. And then that will make it more accurate. Also, there's a baseline. So for example, we can put the baseline on the head, or you can put the baseline on the foot. If you put a baseline on the foot, it's a lot more accurate in comparisons because you can't be floating. So the foot is, everybody's on the same floor, but different people have different heights. So it actually depends on the situation. Certain work sites, let's say in a work site, the foot might be occluded or blocked. Then we have no choice but to calibrate on the head. But you calibrate on the head, it's fairly okay because people on the work site, you won't get a dwarf or a kid walking around the work site. So roughly adults. So but basically, good question. It's not just simple distance using pixels. That's a simple way out, which doesn't work in real life.
Okay, thank you, Cassidy. Okay, I think in the interest of time, there are some questions which we will not have the time to answer now. But don't worry, we will get back to you offline. And if you have any questions that you are too shy to ask, do drop us a note to info@toppanaquaria.com. Thank you everyone for staying with us throughout the session. We hope that you have enjoyed the session as much as we do. But most importantly, do remember to head over to our YouTube channel, subscribe to our channel, and give us a big thumbs up. We have now come to the end of the webinar seminar. Thank you.